Hey Leo,
Hey,
how do you check if your Bitcoin is compiling?
so as it's compiling, you should see the output in the terminal. I'll show it off today.
Okay.
I'll show it off what that should look like. It does take a while, so I'm not gonna wait for it to finish. And I've also run into issues like compiling it myself, mainly around memory. So for example, on the M2 machine, you can compile Bitcoin quite nicely. It takes about an hour. But if you want to run Bitcoin at the same time, then there's not enough memory, and then the compiling will also terminate. So ironically, in the future, if you want to upgrade compiling Bitcoin on the M2, you kind of have to shut down Bitcoin for an hour. And the other issue I ran into was that compiling Bitcoin does take about six gigabyte of space on the server. So if there's not enough space, then it will also eventually fail. I think Bitcoin D needs not just 2 gigabyte of RAM to run, but also 2 gigabyte of RAM to compile. Maybe from those who are already here, maybe you could quickly type into the chat what your status is. For example, if you're already syncing, or if you are compiling, or if you are done syncing. That'd be very interesting to get some downloaded Bitcoin Core. 80%, pretty good. Awesome. Because that kind of then determines what we do next week. We could either next week just go on with installing LND, or if most of us are still syncing, then we can also just do something like install Tor. Great. Yeah, it looks like we'll I'll show it off today still, and I'm going to start now. I'm going to share my screen again. I hope you can see my screen. Here's the guide. Here is my, how do I do this? There's a way to kind of, here. Ha, does that look bigger? It does, kind of. I hope you can somewhat see what I'm doing here. The first step was to make the Git directory, simply to keep ourselves organized. So all the code that we later need, all the code that we want to install, we can put into this Git directory. So then as we use ls, kind of list, we see this Git directory, can we move in there? And now here, I think the command, so we can navigate to the GitHub repository, Bitcoin/Bitcoin. That's where the code lives. That's all of Bitcoin code. If you find a typo in there, you can correct it and become a Bitcoin Core developer. That's how easy it is. So that's quite fun to navigate. The command to clone this is, yeah, that's a funny error with copy pasting. So command git clone, I think some of us have noticed that git clone is not always installed. Here. So if it isn't, we have to run sudo apt install git, but in this case it comes installed by default. So this is downloading all the code into the folder Bitcoin, which is about, yeah, it should be about 80. No, it's much more. It's about 250 megabyte of data. So that's a lot of Bitcoin code. That's mainly tests, actually. Also, when we compile it, we're going to notice that most of the stuff that we compile are tests. But tests are pretty important. We don't want to accidentally run some kind of bugs in Bitcoin. So the node does a lot of verification. There's a lot of security features. So we move into this directory. And before we can compile Bitcoin, we need to prepare our machine. There are a ton of kind of packages that we need so that our computer understands what code, how this code compiles. So there's a lot of, including Python, a lot of packages that we kind of need for our computer to understand this code. We can copy paste that in here, and that just will install all these packages. That's also a ton of, see, all these packages have all dependencies. So in the end, we install like about half a gigabyte of data onto this machine, which I have to say is surprisingly fast, also because, of course, this data is mirrored on the cloud hosting provider, making it very easy to kind of just grab that all these packages from the server and installing them. And that shouldn't take too long. We're about 30% through. The one confusing thing in Linux is that different kind of programs or different kind of source code installs differently. And this installs in a very raw way, but then also in a highly configurable way, in a way that kind of makes it difficult to compare one Bitcoin installation to the other, because it highly depends on what hardware is available on your machine, what software is available on the machine, what kind of features we want. We can like disable a lot of stuff in Bitcoin. This just tells us that here it's that it's not expecting direct kernel, so that it also wants to install this, and then it also wants us to reboot this, which is what we're going to do now. Sudo reboot now, kind of closes the machine. It takes about a minute for the machine to boot up again. In the meantime, we're probably going to get these like connection errors while the machine is not responding. As we'll see how quickly that actually goes. There might also be a lot of other updates. So this is a newly configured machine that, I haven't really run any updates yet. So we might do that too, and I might show you how that works. So Bitcoin Core compiles in a relatively raw way, which means we have to first configure it, and then we have to, in which case we could pass it a lot of parameters, for example, on what kind of databases we want, or how we want, what packages we want to. So there's actually no updates that need to be applied, so that's great. So we're going back into the Bitcoin directory, and I think there's a script that we run, auto-generate, and this auto-generate script kind of goes through our machine mainly and just looks for what's there, kind of to prepare then on what exactly to install, and also so if this script were to fail, then most likely we would need to install some other kind of packages, or we would need to pass it some kind of flags. But on your regular Ubuntu machine, it should all, as long as we have installed all the packages, it should all work well. But it is something where we have to kind of look out for. Do we see any error messages in here, or does it all conclude? So the next thing is the configure flag, and you can kind of see what it goes through. So it makes a lot of checks that help us find out if the installation later, or if compiling that software later is going to succeed. Because of course, if we were to only run into these issues in compiling when we are actually compiling, then we would waste a ton of time, right? Imagine you run into some issue 30 minutes into the compiling command, and then you have to solve that issue, and then because some package is installed or some dependency is not met, and then you have to compile again only to find another issue. So this script here kind of checks. You can see there's some things that it doesn't support, right? It checks if Python 3.8 is on my machine. Python 3.9 is also not a machine. Python 3.10 is also not on my machine. And depending on whether it finds these things or not, it handles things slightly differently. And it doesn't really matter. Not all these things need to be on there. There's a lot of support for older wallets, for example, that has eventually been dropped. And if you were to want to, for example, load a Bitcoin wallet that you created in 2010 and see if your tens of thousands of Bitcoins are still in there, then, for example, a regular Bitcoin installation might not be able to do that, but you have to pass it specific flags for which you then need additional packages. And maybe we find some interesting ones. There's also some interesting ones that have like actually broken Bitcoin. For example, the database for the wallet. Here, this is also a relatively new one, checking whether the wallet can be built for SQLite. So yeah, lots of cool, interesting stuff in here if you ever want to learn more. But we're just going with the very vanilla Bitcoin D because we're primarily going to use it for LND, so to run it as a backend for a Lightning node. And for that, we just need the defaults. But if we ever were to use something special, then we can go back and compile it in a special way. And for that, we might need to install separate packages. So here in the end, starting from here, this is really what we're going to compile. So this is kind of the file that it has now created. And this file is partly based on our configuration and partly based on our machine. What are some interesting ones here was tests. By default, it will also make the tests. We could also just say it's going to go a lot faster if we tell them no tests. Then here's an interesting one like Schnorr signatures. Like in our case, we don't actually need those Schnorr signatures because we're not going to use Bitcoin D to sign transactions itself. All these transactions are going to be signed by LND, but might as well keep it in because why pass it complicated flags? And maybe we do want to use the node later for other things as well. And maybe we even do some workshops on that. This, for example, is our chip architecture of that server. So if you're running it on a Pi, then it's going to say something like ARM64 here. What are some other interesting things that I understand? I also don't understand all of these things. Here with wallet is an interesting one. Because you don't actually have to have a Bitcoin wallet, and for a lot of, for example, for LND, we don't need this Bitcoin wallet. Berkeley DB used to be very common and caused a lot of problems, so that's now been deprecated. But if you have an old Bitcoin wallet that's let's say 10 years old, then you need this flag to be able to read it. So this also doesn't compile the GUI, so it kind of detects that, hey, it's a server. This is not a machine to run that needs a window, but if you're compiling it on your laptop, for example, maybe this here turns to yes. CMQ is something that we do need later because we do want to connect the Bitcoin node over CMQ. I'll explain in LND class a little bit what that is, and so on and so on. Here's information about our OS. And then here, yeah, more flags. The command to compile this now is just make. And this is what it looks like if it's compiling. This is going to take a long time. And you can see all these .o scripts. That's really kind of turning all these different functions, or rather all these different, they're not scripts, all these code snippets into binaries that it can then later put it together into what makes up Bitcoin. LibBitcoin is written by Eric Voskuil. He's not so far away from us, so maybe he'll give a talk sometime too. It's very cool to go through this and like kind of look at all the history, but that's a very separate course. I can be totally hypnotized by this. I can stare at this for hours, but we're going to abort this here because we don't have the full hour to really watch our node. So aborting is usually Control C. And then that's here, error 1, interrupted. No surprise because I did interrupt it, and I'm going to exit this window because I'm going to switch to a different one. So kind of like in a cooking show, of course, we've prepared everything in advance, right? And then what did I hear? Here, this one wants to be updated. This is something where that's kind of easy to remember, but maybe also worth writing down. Sudo update is the classical command to kind of fetch all the latest packages that are available. And this is something where if the node asks you to update it, often it's a good idea to just do this. Maybe it doesn't have to be done every day or every week, but maybe every month it's a good idea. And then to actually install them, so sudo update only fetches the updates, it only downloads them. And to actually install them, we then run upgrade. And then this gives us here a little overview over which packages are no longer required, which new packages will be installed, Python 3 magic, who knows what that does. And then tons and tons of packages that will be upgraded, including the package that we use to upgrade itself. That's a bit recursive. Hopefully that will not take us too long. And then we can already easily continue. Sometimes it also wants us to restart. In Linux, that tends to be not very important. These kind of many people run Linux machines for years and years without ever restarting them, especially servers. Some servers can't even be properly restarted because of all the dependencies they need for whatever is running on them. Our server should always be safe to just restart it. We just might have to later then manually check. So as we configure these things now, we always have to manually start Bitcoin. And then once Bitcoin is started, we have to manually start LND. And then we can use our Lightning node again. And I think that's actually like a fair default because these machines don't need to be restarted often, or they don't turn themselves off magically. And and we will notice relatively quickly if our node is offline, hopefully. So of course we could configure our machine to, on a restart, automatically start Bitcoin and automatically start LND. And that would make it relatively easy to just click on the shutdown button and click on the start button and everything's running again. And we might figure out later on how to configure these things. But for now, all we're going to do is just manually start them whenever we have to. Often when you get a new server, it wants to have tons and tons of updates. But of course, also software is a very volatile thing. If one package is updated, then lots of other dependencies need to be updated as well. And that's how these things can take a while. So on this machine, I already compiled Bitcoin Core. So once this update process is done, I'm going to show you then how we finally install it. And once we have installed it, I'm going to show you the configuration, and then we're going to start it up. And then, of course, it's a little bit synced already, but we're just gonna watch the syncing process a little bit, see what else we can do with this. 87%, any minute now. What else can we do in the meantime? I could kind of open a new terminal and we could play around with that server a bit more. But then who knows how quickly that goes. It's also kind of scary. We're installing so much things. We have no idea how to verify all this. Who knows what is really being installed. into our machine here. Almost done. 99%. And once we're done, I can go back into the Bitcoin directory. Here we go. Oh, a few more seconds. So I can go back into our Bitcoin directory. All the code is in here. And the command to install it is sudo make install. And the sudo here in the beginning, it just stands for super user do, I believe. And super user meaning certain, so by default, we don't have permissions to touch every part of the operating system. Partly that's for security and partly that's to prevent us from making mistakes. And what this make install command does is it places the files that we have created in our compilation progress, and places them where the computer can run them. But these, wherever the computer wants to place them, is kind of reserved as a restricted space. So we need to then use this sudo command. And now it's taking all these directories, right? So it places these commands in /bitcoin/src, stands for source, and then takes these. Takes kind of the programs that it has compiled. So Bitcoin D, Bitcoin CLI, Bitcoin TX, Bitcoin Wallet, Bitcoin Util. These are all separate programs together with the test, and then places them in, I think we're going to find out, like it's probably user local bin or something. So places them in one of these directories where all the programs are being kept, so that later when we execute program command, it knows where to look and it knows where to find the program. We could also, like hypothetically, we could also manually put them there. But then of course we would need to check like what do we really need to put, what is necessary for this to run. I think for our purposes, we would theoretically only need here Bitcoin D and Bitcoin CLI, but then might as well. So then here seems to be almost done. It places them in user local bin, yes. And there's even some more programs, test_Bitcoin and bench_Bitcoin. I do not know what they do actually, but who knows, maybe they are useful for us later. So there's no errors here. Don't see any errors. So that seems to have worked well. And now to configure Bitcoin. The first instance is to make a directory called .bitcoin. That's just a convention. .bitcoin. When a directory starts with a dot, it usually just means it's hidden. So if you were to navigate to this now with a file explorer, then you wouldn't see anything, just because it's not meant for us to place our pictures or place our stuff manually there. It's meant for the computer to kind of hide its own file. In this case, this directory already exists. So if you click on here in ls, for example, it doesn't show you this directory. Only if you click on ls all, then it will also show you the directories that start with dot. And so there's here the .bitcoin. But we can just go into this with make_dir.bitcoin. I know that's make mkdir means make directory. We want to go cd, which stands for actually no, command directory. This means enter. We enter this directory .bitcoin, and in here with nano is just a way to edit files in the command line or to edit any kind of text. We're going to edit the file bitcoin.conf, so the Bitcoin configuration file. And in our case, by default, we only need these two configurations. Although we are going to add others later when we install LND. But for now, just to sync Bitcoin, that's all we need. So if we start a command here with the £, then that means that Bitcoin is just going to ignore reading all of this. But if we start a command just like this, then Bitcoin is going to try to read it. And in this case, it has to be one that makes sense. So what we can enter, what's a good one? full RBF. What is it called? Memory full RBF. Mempool. I think it's mempool full RBF equals 1. And that means that we're going to allow replacement of transactions even if they don't flag for the RBF. So we save this file with Command O and then OK. We exit the editor with Command X. And we're back here. We can go back to our main directory. And now to start Bitcoin, all we need to do is, well, that's also an interesting one. So we can pass Bitcoin D configurations either by editing the command line, by editing the this configuration file, or we can pass them to them with 2 dashes. And the difference is if it's something that we want to do every time, if it's a configuration that we want Bitcoin D to have every time we start it up, then it usually tends out to be better to just add it to the configuration file. For example, here we can do daemon1. And if it's something we want to do only once, for example, let's say we need to resync something or we need to read something in at startup, then we're just going to pass it here at startup. So ideally, this command will work, and we'll just say Bitcoin D, Bitcoin Core starting. Great. To verify that it's really starting, we're going to use the tail command. A tail really just means you follow something. Tail -f, -f stands for follow. And we're just going to find our, so you remember here in the configuration file, we mainly defined 2 things that are important. And one is the data directory. Since we don't want, by default, Bitcoin Core will save all our data onto the same hard drive that we're running on. But in this case, we have an extra volume, like an external directory on which we want to save everything. And so that's what we configured in the last session, or rather 2 weeks ago. And we created this new directory called /mount/Bitcoin, pointed it to our external hard drive. And now we want to tell Bitcoin Core that as it's starting, it should please look up this, please store all the files in here. And the other thing we wanted to verify, we wanted to add is prune. So we want our Bitcoin Core node to forget all the blocks that are kind of older than, let's say, 19 gigabytes ago, because we still want to verify every single block, but we don't really want to keep everyone because we have to pay for storage space. So now to see what's happening, we can find our debug.log file in this directory, right? We told it here. And as you see, something's happening. It started here a few seconds ago with importing the mempool transaction from disk, even though they're not there because it's not yet fully synced. Then it tells us when it's connecting to which new peer. And now it seems to be connected, and it tells us this update tip. Every time it kind of finds a new block, it will tell us about it by saying update tip. The tip meaning the latest block that it has. This is the block hash. So you can see it starts with zeros. This is like representative of the difficulty. It has a height. So we're now synced up to block 551,641. Versions are quite interesting, but not so much relevant for as we're doing here. This is the proof of work. These are I don't know if these are the total transactions or just the UTXO set. Here we have a date, so that's the date this block was mined. The progress in percent, meaning, yeah, how much does Bitcoin, this is really just a poor estimate, but how much does Bitcoin Core expect us to, continue syncing? So in this case, who knows how long after syncing, but it's still going to take longer than that. And then later there's like how much it's keeping in memory. So that number is going to grow bigger and bigger and bigger as it runs until eventually it consumes all the memory. And all the so here we can use the command top to see kind of the resource. Yeah.
I was just going to ask you a question back on the config there.
Yeah.
For the data dir, I took that out because I was thinking, well, I'm on a laptop. I've just got a single drive, right?
Yeah.
So is that just for the Luna node, or?
That's just for whoever's running their Bitcoin node on an external drive. So if you're just running it on your main drive, then you just take it out.
Okay, so that I did that right.
Yeah. And the prune, exactly what kind of number you put in, also depends on how much space you have. So I think it doesn't really make sense to prune it to more than 100 gigabytes. So my recommendation would just be like prune equals 100,000. That's the maximum you put there. Either you don't prune it at all, or you prune it to, let's say, 100 gigabytes. It's an arbitrary number, but for example, pruning it to 400 gigabytes or something doesn't really make sense, because then you keep almost all the transactions except for the first 2 years or something.
Yeah.
And so, but you should also kind of generously leave yourself space for other things. So L&D will later probably also need something like 10 gigabyte to comfortably run. So that's something we might want to keep in. We might want to keep in mind later. But this prune number is also very easy to change later. So if you later ever run out of space, for example, because so this prune here actually says 19 gigabyte. Here in the comments it says 20 gigabytes. The reason for this is I started originally out with 20 gigabyte, and then I ran out of space, and then I kind of took a gigabyte from it. So if you ever run into that problem, then it's also very easy to fix. If your Bitcoin core node ever crashes because it says I'm running out of space, you can just take a gigabyte away from that. So this hard disk has, or this SSD has 25 gigabyte of space. But of course, when we say prune, what we mean is pruning only the blocks take up 90 gigabyte. And as we can go into the Bitcoin directory here and see that, what is the command tu? So we can see that here in blocks, it's actually taking up 18 gigabytes now. And that's what we mean with prune. But then there's some other, for example, here there's the chain state or the block index, which also takes up space. And altogether, it actually only comes here to 21 gigabyte. So I don't know why it ran out of space for 25, but you can imagine that when we tell it to prune 20 gigabyte, then the actual space it takes up on the disk is still a bit more than 20 gigabyte. So back to the top command, this will show us all the processes that are running here on the right side. It will show us for how long they've been running, and it will, most importantly, it will show us the CPU and memory power that they consume. So in this case, it's consuming 24% of CPU and about 25% of memory. And I would suspect that as this, as we keep running Bitcoin Core, it's just going to eventually consume 100% of either of the two. So it depends a bit on how, it depends a bit on what the bottleneck is. But if you are running VPS on Luna node, then don't forget that you can go into your admin panel and click on the node and then activate kind of like CPU acceleration. And that allows your node to, if it needs to, buy more CPUs up to a certain point. And I think that will cost you a few more dollars for the initial sync, but it will also speed up things considerably. So in the very beginning, as you download Bitcoin Core, it's mainly limited by how much bandwidth you have, because it just mainly downloads blocks. And later on, it will need to verify all these blocks. So then it suddenly needs a lot of computational power. You can also imagine that the early blocks, there's not a lot to verify because there are no transactions and there's no signatures and there's no, there's no actual data in the block. So then verifying the proof of work is relatively easy. But later on, as these blocks become full, then your node wants to verify every single transaction in the block and wants to compute and so verify the signatures and then verify the Merkle trees. And that costs a lot of computational power. And then, eventually it also just needs to create like a UTXO set. So as it syncs through, it needs to know whether a transaction is spendable or not, to know if it's valid, and that also consumes a lot of memory. And then, of course, we have the famous mempool that also consumes memory that we can configure in our config file. So there's some benefits to making the mempool smaller. There's even an option to not have a mempool at all. There's also, so if you're running it on a very bandwidth constrained computer, then you can even turn it off, that relays transaction. In that case, it will only take new blocks. And the downside is if you have this configuration, then you don't have a way of seeing unconfirmed transactions because you don't have a local mempool. But once a transaction is confirmed in a block, then you will see it. And that means that you only need to download a little bit more than like 2 megabytes every 10 minutes, which is very convenient if you are running it on a low bandwidth environment. And I think that's actually already everything on the show. So this is just gonna sync like this. It's worth it to regularly check in, like maybe once a day, check in to see if it's still syncing. There can be, so eventually you might run out of memory, or you might run out of storage, or who knows. So it's good to just make sure it's still running. You can also just keep this running in the background. But even if we were to log out here and we were to log in, then as long as we don't restart, then it's still gonna run. And actually, I think that's all we wanted to show today. I'm gonna stop sharing my screen now. Maybe, so I didn't actually see any of your comments. So for Curtis, theoretically, everything we do now, we should be doing on the, like in your case, on the VPS. So then Homebrew shouldn't really be like relevant because Homebrew will only install things on your local Mac. And theoretically, everything we do from now should kind of be just done on the VPS. And yeah, we do have to install some software sometimes in the VPS, but that, since it's not Mac, it shouldn't be Homebrew, but it's probably going to be like Aptitude or Snap or like a manual installation. Any other questions? Anyone got stuck somewhere around here? Yeah, you might be installing things on your Mac rather than your server. I think if you were to install it on your server, you would quickly notice that like Homebrew would like throw errors because it's not already installed. Anyone else stuck with something or have questions?
I have a more general question.
Please.
Should we be installing the Ubuntu VPN? Does it have a basic VPN on there? Should that be installed while Bitcoin's running?
I think if you want to hide the fact that the server that you're using is running some kind of Bitcoin software, then I would recommend putting everything behind Tor. And I can write a quick guide to how to install Tor. It actually is relatively, well, at this very moment, it's a bit annoying to install Tor on a Ubuntu machine because of just how packages are handled, but very soon it will be quite easy. So theoretically, it should just be like a sudo apt install Tor, and then we would just have to configure Bitcoin D. I can definitely write a guide on that. It's just yeah, I tried it the other day and it was a bit annoying. and it shouldn't be. So I thought I would wait for the fix. I think proxying as a VPN is an option, but I think Tor is like a much more. It is also a much more like useful alternative because if you run Tor, then without having to worry about port forwarding, you can very easily let others connect to your Bitcoin node or connect to your LND node through a Tor onion. So I think, which is even kind of a must later for those who run their Lightning nodes at home, we will need to run Tor because we will need to get our node an onion address so that others can connect to us from the outside without us having to worry about port forwarding or something. So on a VPS, I think it's totally fine to kind of associate the VPS with the IP address of the VPS of Bitcoin. It's not ours anyway, and and then enabling Tor just is an extra option that we might want to be able to make outwards connection to Tor only nodes. So if I talk about my personal node, then that's a Tor only node. It's running at home. It can only be reached via the Tor network, and so that means it can reach outwards both Tor nodes and ClearNet nodes, but a ClearNet node cannot reach me. So even if we are running ClearNet node, we might still want to have kind of it's called a hybrid mode, where we make ClearNet connections to other ClearNet nodes and Tor connections to other Tor nodes. That way we can reach everybody in the network and everybody can reach us, and that's kind of the optimal configuration. Yes, we can, and ideally we will do that with systemd, and we will probably configure it that way, but more towards the end as kind of like optional guides. So Bitcoin D and LND can be, like, let's say not relatively easily, but without much trouble, be configured to start automatically at when we reboot. But for LND, we will still have to, after this reboot, kind of manually pass it our unlock phrase, because by default, all the Bitcoin keys on the device will be encrypted. And so LND wants, every time we start it, it wants to be kind of unlocked, meaning we pass it our decryption key. So then it's not like super practical to have it start by default if we still have to manually go in, but it will, kind of make it easier for us to keep it running for sure. Who else has a question or a problem they ran into? Otherwise, I'm going to conclude the session. For next week, what we're going to do is, I believe most of you are done syncing, or I expect them to be done syncing this week. So then we will go on next week already to install LND. We will also compile LND from source. We will also give the option to just download the binaries. Compiling LND from source is like slightly more complicated because we first have to install Go. LND is written in Go, Golang. It's kind of like the Google language. And so we first have to install Golang, and then we have to download the LND source code, and then we can compile this. And I'm also going to give the option to, instead of LND, install litd, which includes LND. So litd is a package that includes a lot of other tools that we might find later quite useful. For example, if we want to connect our node to our personal phone, for example, then litd makes this much easier. If we want to manage our liquidity or inspect our channels or create invoices through a web UI, then litd will also help us with that. And then I think I think next week, since we are going to be able to go through installing LND and configuring LND within within another 45 minutes. We're also already going to start L&D. So we might already reach like the objective of having L&D running next week. And then we can kind of after the session get started with channel openings. So if everything goes well, then in a week you'll have your first channels, and I'll pray that channel fees are down. Thank you all for your attention. Thank you for Eric for the great advice, and to Murdoch Media for recording this and putting it online. Thanks to the Vancouver community for being part of this. And then for those who are in Vancouver, I'll see you tomorrow at BitDevs from 7 p.m. Bye.